Hi, everyone. Welcome. I am here with Ellen today, who is going to be sharing a little bit about the data visualization that she submitted for the annual Data Connect Conference Data Viz competition. Before we dive into that, I want to share a little bit more about the competition and the Data Connect Conference in the event that you're joining us for the first time and have not heard of the event or are wondering what the heck we're doing here. So, to give some background, our organization, Women in Analytics, hosts an annual Data Connect conference here in Columbus, Ohio. Within that conference, we also host this DataViz competition that's supported by our friends at Apexon. Basically, what happens is we get hundreds of these applications in every year. With the help of the team at Apexon, we somehow narrow it down to a top 10, which is incredibly difficult to do if you haven't had an opportunity to jump around on the top 10 presentations and check out some of the previous year's winners. You will see what I mean by that. So we've been doing these interviews over the last couple of weeks. We have a few additional ones coming up as well, just to give these folks an opportunity to dive a little bit further into their data viz, showcase what they've put together, share a little bit more about themselves and their background. And then we will show you where you can find these vizzes, where you can navigate them, and where you can vote for your favorite. The top 5 from this virtual vote will have an opportunity to join us in Columbus for the event. We set up a really cool kind of art gallery style interaction experience with these vizzes so that folks who are attending can navigate through them, play with them, help us narrow it down to a top 3 by voting in person. And then there are some cash prizes, trophies, all that good stuff at stake. So thank you, Ellen, for joining us today and for putting a viz together and submitting. We're excited to hear a little bit more about you and the presentation you've put together.
Sure. So I guess first things first, thank you very much for the opportunity to have been shortlisted for the competition, and also to be among such kind of incredibly talented women in this field. Like everybody else's submissions were incredible. So first things first, and thank you there. I guess I'll launch into kind of the title of my visualization, and then I'll give you a little bit of context. So my visualization was called, or is called, The Race to the Moon Volume 2, and it essentially details the history of lunar exploration from 1958 all the way up to the projected missions that we have slated for this decade. And before I kind of go in any further detail, I'll just give you a little bit of a brief overview as to what you can expect from this presentation. So first, I'll give you a little bit of an intro as to who I am and what I do. Then we'll move on to the what. So what actually am I visualizing in this visual that I submitted, and then the why. So why did I pick this particular topic, and why should you care about it as well? And a little bit as well about the how. So how I went about designing it, how I created the concept, and kind of how I created the various different encoding systems to translate data topics into visual elements. And then if we've got time, I will do a little bit on the future of the viz, but also the future of the moon landings and kind of where we look to be this decade. So a little bit about me. As Kelsey said, my name's Ellen. I often go by Elle, and I am a freelance information designer. I've been doing this will be my 2nd year. My background before that was centered around chemistry. So I was a chemistry student. I finished my master's in 2018, and then I went along the consulting, data engineering and analysis route at a financial services company. So a bit of a varied background, but my experience in both of those places really does feed into the work that I do in the information design space. And I've been super lucky to work on projects at the moment that really align with things that I'm passionate about. So a lot of the work that I've done kind of centers around environmentalism and sustainability, and also accessibility, with kind of a focus on digital accessibility and making sure that the work that I'm creating is approachable as it possibly can be. But yeah, enough about me. This presentation is about the visualization that was created for this competition. So I mentioned that it was called The Race to the Moon Volume 2, and essentially what it showcases is a static infographic. So you can see a mock-up on the right-hand side. I'll give you some close-ups as we go through the presentation, but from a broad perspective, it details every mission that we have ever launched to the moon since 1958. And it takes us all the way through to the present day in this kind of like roadmap style racetrack. And then it also showcases all of the potential missions that we have on the horizon for this decade. And so the idea behind this was to shine a light really on the history of discovery and exploration with regard to the moon, and to get people really excited and engaged with kind of what we have coming up in the future if they don't know about it. And part and parcel of that, I think, that is tied quite closely to the story is the human element that comes with space travel and exploration. And I think that comes from looking at how we have developed our technologies over time. So when we dig down into the data, you'll be able to see that in the very early days, towards kind of the late 1950s and the early 60s, we were seeing very quote unquote simple missions to the moon, where we would have one mission that would have one spacecraft. But you'll notice that as you walk all the way through and scroll down the visualization, that as we come into the early 2000s, that we're starting to have more bespoke, more nuanced missions. We've got missions that can have anything from up to 6 spacecrafts, which I think makes sense from an efficiency standpoint, in that if we're going to do this really, really expensive thing, we might as well make the most of it and send as many as we can at the same time. But I think it really goes to show just how far we as humans have come on the engineering and the scientific discovery side. And it's not only the kind of evolution side of things, it's also the representation of what successes and failures that we've seen, because quite interestingly, not everything has been a success. So if we take lunar landings, for example, I think the stat is something like half of all lunar landings that we have sent have been successful. So that means half of those were failures as well. And I'm sure NASA and all of the various different space agencies aren't there celebrating their failures, because it's quite a costly failure. But I think that they would admit that it's the failures that they have undergone that has given them a lot of insight into how to do things correctly going forward. So they've learned a lot from those things. And I wanted to highlight that side of things as well, that it isn't always a kind of tick and done, we've gone to the moon. It is this kind of ever evolving science that isn't always 100% guarantee of success. And then just on the name, the Volume 2 element is actually an ode to the initial space race that we saw play out between the then Soviet Union and the US. And I thought what was quite interesting was that in the 1960s, we were seeing, I think it's around about 60 something missions that were launched. And then following on from that, we saw as the decades went by that our interest in space travel and lunar landings kind of waned a little bit. And I think a lot of that was to do with public sentiment around the time, not wanting to spend money on it. And the money that does get spent on this project is like in the tens of billions. So I think that's part and parcel of it. But one exciting thing that we're starting to see with this decade is there is this uptick in the number of missions that are being slated for launch in the 2020s. And it's very reminiscent of that earlier space race, except now we've got a lot more countries involved in the race. So I also thought, before I dig down into the design and show you all of the iconography that was developed, I wanted to really kind of dive into kind of why I picked it. And it's very loosely tied with what I was just talking about. But the first part is essentially the exploration and discovery side of things. And for me, I've always been fascinated by science, space exploration, all of that stuff. And I think it's incredibly exciting to be looking at something in the space with such curiosity. So if I took an example, like if we looked at some of the orbiter spacecrafts that you'll see in a little bit, we've got an example of a man-made object that has been engineered to orbit the moon, which in itself is an incredible feat. So nobody's taking away from the fact that there is a lot of science that goes into that. There is a hell of a lot of engineering that goes into it as well. But I think for me, the really interesting part of that story is that in order to even apply the engineering and the science, we needed somebody somewhere to ask questions and be curious and say, I wonder if we could do this thing, or what happens if we do this? And it's that part of it that I really, really I loved. And I think I wanted to use the moon and this visualization as a way to explore that love of discovery and curiosity, because the curiosity itself doesn't start and stop with NASA. It's something that we do in our everyday lives across lots of different avenues. So again, it's incredibly tied to the human experience. The other part, as I kind of mentioned, is that we have a renewed kind of interest in lunar exploration. It's something that we've seen a significant uptick in the past decade and hopefully in the next couple of years as well. And I wanted to kind of go in and give a little bit of context as to why we're seeing that, because one, it will give you a little bit of color to the actual visualization itself. And two, this was kind of my entry point. When I started learning about just how many missions there were going to be, my immediate thought was, well, why? So I think that when I was looking into this, my research showed me that it all kind of boils down to water, which you may be thinking, well, what are you talking about, Ellen? But the water element of this is so interesting because it was essentially discovered, I think it was in 2008, water ice was discovered within the craters of the moon at the poles. And discovery of water, for one thing, is amazing because it means hydration for astronauts. But the second component of that, and the reason why scientists are sending teams and teams of people to the moon, is because water is essentially made up of hydrogen and oxygen, and they're the key components of rocket fuel. And what that means is we could essentially see a lot more of the solar system if we were able to take our rocket. So if our rocket was on a trajectory to Mars, instead of us having to put enough fuel in the tank for both ways, which is incredibly heavy to do, we could essentially get to the moon, then use it as a fun kind of space gas station, refuel in orbit, and then be on our merry way to Mars, which is incredibly exciting because it means that we have a lot less weight in the actual space launcher itself, which means we could take more people, so more astronauts, potentially more very rich space tourists, less interesting, but also the capacity to bring more cargo and more scientific equipment, which potentially may lead to even more discoveries. So I think that's the beauty of this area, and the beauty of space is a discovery as small as water can snowball into this incredible trajectory where we're seeing people theorizing that we could potentially go to the Mars in a much easier fashion than we had originally anticipated. So that was part of the driving force behind the visualization. Was I really wanted a way to show this uptick in missions. And then lastly, from an accessibility standpoint, I was doing a lot of research and trying to find data on the missions themselves. And the data is out there. It's stored in a lot of disparate sources, and the data is very vast. So I think in the visualization itself, we are looking at 193 missions and their subsequent data points. But I was realizing that there wasn't a whole host of resources that were available at like an entry level perspective. So it was a lot of the data that I was seeing was quite hard to digest. So I really wanted to take something that I was passionate about and distill it down into something that everybody could hopefully look at and find engaging. So in terms of the how and the concepts, I've broken this down into kind of three core pieces. I've briefly spoken on the space race being kind of the driving force behind the inspiration, but the more and more I was thinking about that, the more I was thinking about, well, how could I use this metaphor of a race throughout the visualization? And it got me thinking about, well, this was originally a two-horse race between the Soviet Union and the US, but now we're seeing a whole host of players involved in this race. So we've got China, India, I think Luxembourg have sent something to the moon as well, Canada, lots of countries that are still using the space race as a way to score kind of political points. So when you land on the moon, it's a real signifier of a, a civilization or a country that is kind of highly evolved and looking for discovery and exploration in new places. And so it's something that countries are still very, very keen to explore. And so I started thinking along those lines. I thought, well, why don't I visualize this as a board game kind of style racetrack, but rather than having a start and a finish, you have the Earth and the Moon. And so that was the driving force behind that, the actual design of the racetrack system. I then started thinking about, well, how do I want to display the missions themselves? And the chronological order was really important. I wanted to ensure that anybody could go in and see the 1960s and look at the first mission that was successful in the 1960s, or the first crewed mission that was successful in the 70s or 60s or whatever it is. And as I was delving down into the data and realizing just how bespoke each of the missions were, I was realizing that when I was designing the missions, there would be one mission that might have one spacecraft and one mission that might have 6 spacecrafts. And it was quite difficult to kind of plot them against each other. So plotting them in a uniform way was quite difficult to do because of the nature of the data not being incredibly uniform and being quite customizable. So I was thinking, oh, how can I do this? How can I do this? And that was when I was looking at imagery. So you can see some of the imagery that I've got on the right hand side here, and it showcases this asteroid belt. And I thought, oh, that asteroid belt looks very similar to what I've imagined in my brain as being the racetrack. I wonder if I could use this concept of asteroids floating within the asteroid belt to represent the different space missions, because then I could get away with them being a little bit more fixed together, like almost like puzzle pieces, like nestled along this asteroid belt. So that was what I ended up going for. And I'll flick onto the next slide. Hopefully you can see on this left hand side, we've got Apollo 13, Apollo 12, and between that, the lunar E8 number 405, less catchy, nestled between the two of them in this kind of fixed kind of nestled way that we see asteroids generally tending to float along that asteroid belt. And then, so that was the overarching concept. I then started thinking about the design elements that I could bring in. And I really kind of wanted to have fun with this because I'd never done anything to do with space before. A lot of my work, as I mentioned, is focused in the sustainability sector. So I really had some fun with this piece. So you can see here, a lot of the text that I was using is kind of futuristic text that you normally see in like Star Wars or those kind of movies. And you can also see that the background is like a dark blue with stars to replicate the night sky. So I had a lot of fun with that side of things. And then I also looked at the actual spacecraft themselves. So on the right hand side here, this is a lunar orbiter, and this lunar orbiter is actually in visualization earlier on in the 60s. And these orbiters were used as the precursors to the Apollo missions. So they were essentially spacecrafts that were gathering lots of data about the moon and feeding that into the crewed Apollo missions. And I thought, well, when I look at this spacecraft, I see a central hub and I see 4 fixed solar panels kind of spurting off of it. And when you look at more and more satellites, you see that a lot of them are built with this kind of central hub and then spokes coming off of it. And that was something that I was very keen to replicate in the design of my icons and my visualization that you can see kind of here. And I will go on to, in the next couple of slides or so, what all of these funny symbols mean. But essentially for this slide, I just wanted to pull out the fact that we have a central hub and then we've got spacecrafts coming off of it. And like I said, this can be anything from 1 spacecraft to 6 spacecraft. So this hub and spoke model gives me a lot of leeway to show as many spacecrafts as I could possibly cram around the circle. And then last point on the design side of things, I also was looking at how can I enrich this kind of space metaphor even further? And I was looking at the kind of blueprints of rockets that you often see in like James Bond movies. And normally, as you can see on the right hand side, they are very technical line drawings, just clean with just one color. So they're normally always done in white on a blue background. And you can see on this image to the left that I've also tried to incorporate that in my design. So the encoding, this I'm sure is probably the part that most people are interested in, and this is visual encoding is essentially something that we employ in a lot of data visualizations that looks at how can I take this data and how can I translate it into a visual element that has some form of meaning. And so what I was looking at to begin with was the mission status of the final kind of lunar launch. And you can see here that there are generally 6 buckets that they fall into. So we've got whether or not it was successful, a failure, a partial failure, operational. So operational means that if you've got a spacecraft, let's say an orbiter, that is still doing its job, it's still traversing the orbit of the moon, we would label that as being an operational mission. We've also got missions that could be en route, so they're on their way to their destination. And a lot of the missions that we have slated for 2020, these will all be labelled as pending, and their status will update as they go off for takeoff. So here you can see in this example, we're looking at Pioneer 0 on the left-hand side, and this is the first ever spacecraft that was launched, or the first ever spacecraft that was launched toward the moon in 1958. You can see that it was a failure, and that was because I think a gearbox failed and it exploded somewhere down the line, but it was very clearly it did not work. And again, it was a data point that we use to understand what went wrong, how do we change that for next time. And you can also see on the left-hand side that there are other elements that we have tried to incorporate in the individual missions themselves. So we've got data about like the spacecraft names, the name of the mission, launch year, and the operator and space agency responsible for the launch. And again, you'll see that they're less frequent, but anything that has the color orange will represent the fact that that mission was a crewed mission. So all of the kind of Apollo suite of missions that will be kind of coloured in orange. And one interesting thing just to point out here is that the majority of the time a mission is labelled as a success or a failure or a partial failure, but there are some instances where you will have a mission that can have 2 states. So quite famously, there was Apollo 13 that was lauded as a successful failure. And that was because, yes, it did not complete the mission as intended, but there was a separate rescue mission that was completed that ensured that those astronauts that were in danger were returned safely to the Earth. And if I go back a couple of slides, you should be able to see it here. So Apollo 13, you'll see that there's that mixed state. You've got the failure around the outside, but the success in the middle. And there will be some instances that have missions that do have this two-prong approach. The next part was the encoding of the mission type, but I think here you can really see from a design perspective where I was inspired by those blueprints. So it's very simple line drawings, and broadly these will fall into kind of 7 buckets. We've got a flyby, which is where a spacecraft essentially brushes past the moon and collects data. Orbiter, which does what it says on the tin, it orbits the moon collecting information. An impactor, where this is probably my favorite one, but this is where a spacecraft essentially makes a controlled collision with the surface of the moon, and any dirt and debris that gets aggravated during that collision will get studied. And then we have sample return, it's a robot that will go out and take samples of rocks or dirt and then bring them back to the Earth for studying. And then the lander, which we're quite familiar with, and the rover, which you probably would have heard of in terms of the Curiosity rover on Mars, but it does essentially the same thing. It's a remote controlled vehicle that will traverse the surface of whatever planet or terrain that it's been put on. And then most of the time they will fall into those six categories. But there is one other category which I've labelled as other, which will include things like the rescue mission that I just spoke about, and then also things like deployable cameras and relay satellites and things that don't necessarily fit in with the six categories that we have here. And in this instance, you can see that Pioneer Zero was an orbiter. And I quite like this approach here because I think it really showcases how powerful visual encoding is as a system, the ability to kind of take what is quite dense data and translate that into something that is hopefully quite easy to digest and is quite accessible to as many people as possible. And then we come on to the future, and hopefully we have enough time to go through this. But this is essentially where I see the visualization going forward. And I think the thing that is most exciting for me is that with every new launch that we see in the 2020s, I then get to update my visualization. So I think it's a really nice way of using this kind of visualization as a tool to keep people on the pulse of what's happening without them necessarily having to sift through all of the kind of quite dry data that can be behind some of these missions. And this example here actually occurred just a week after I published the initial visualization, and it was in the news. I wonder what it was like in the US, but it wasn't a big deal here in the UK. But I certainly stayed up to watch the launch. But it was essentially the first time that a private company, Intuitive Machines, in partnership with NASA, launched a rocket into space and onto the moon, which I thought was incredibly interesting. And it was also the first time in 50 years that the US returned to the surface of the moon, which is quite baffling. It's quite an interesting statistic. But what was quite interesting again is we had another successful failure status, and you can see from the iconography that I'm showing here, you can see from the press conference on the left-hand side, quite comically, the director was illustrating with a model how the lander had landed sideways. And because of that, it was still deemed a successful landing, but it wasn't able to deploy the other elements of the mission. So there was supposed to be something called the Eagle Cam, which was going to show images of the lunar surface and potentially the image of the lander actually landing on the moon. But unfortunately, sadly, that didn't happen. And so that was an instance where we've got these kind of two states for this one mission, which was, I thought, quite interesting. And it goes to show just how complex the science is. Just because we've landed on the moon before doesn't mean that we are going to be able to land again with 100% certainty. There is always things that will go wrong, but it's also a fact that we're also learning about new ways of doing things and trying new ways of doing things. And I just really love the kind of the visualization that I've got here is a way in which that I can help continue the conversation around like space and space communication too, but in a really fun, accessible way. And then I guess last point for me is I just wanted to end with a quote. So there's an astronaut called Sally Ride, and she was incredibly influential, and she got a lot of women into kind of STEM subjects. But she, upon reflection from her time in space, said the quote, "The stars don't look bigger, but they do look brighter." And I thought, one, that's a beautiful sentiment, but also I think it goes to show exactly what I'm trying to do here. I'm not changing the data in any way. The data is out there, the data is consistent. All I want to do is try and shine like a purposeful light on that data so that more people can hopefully appreciate space and the joy and wonder that comes with exploration and discovery. So yeah, that's it from me. So thank you all for listening, and I've got my links below if you want to check out any of my other work.
Yes, thanks so much, Ellen. This was wonderful. This was one of my favorite visualizations to go through. I think you touched on this a couple of times while you were talking, but I think you put it together in such a visually pleasing way that also provides a ton of information that is incredibly palatable and consumable. So I really appreciate all the effort you put into this. And yeah, it was certainly one of my favorites. So I'm glad we got to chat today.
Oh, thank you very much.
Definitely. And thanks so much for sharing your handles down at the bottom as well. I'll leave those up for a second just in case anyone wants to check them out. And then, yeah, let me share my screen really quick to give folks an idea here of where they can actually go in and interact with this viz and then vote for their favorite. So let me swap these out here. Yeah, so if you are interested in kind of navigating through these vizzes and casting a vote for your favorite, voting is open until April 26th, and then we will be announcing the top 5 who will be joining us in Columbus on April 29th. So again, if you're interested, dataconnectconf.com, dataconnectconf.com. Up here in the right-hand corner, you can go to Data Connect Conference, Data Viz Competition. If you scroll down a little bit here, we've got all of our top 10. You can check out the author, the medium used. You can also learn a little bit more about the viz here. And then if you're interested in navigating that, you can click on this view entry. It'll take you to the page where it's being hosted, so you can actually go through and interact and read a little bit more into the visualization. And then once you've had an opportunity to check out all 10, they are all incredible. So we highly recommend flipping through all of them. You can click here to cast your vote and vote for your favorite. Like I mentioned, voting is open until April 26th, and then we will tally all of those votes and announce our top 5 on Monday, April 29th. Yeah, so thank you so much, Ellen, for joining us today to share a little bit more about your visualization, and we wish you luck.
Thank you, Kelsey, and thanks for the opportunity.